All right, the check exercise tool. So we're gonna go to, let's look at this programming assignment for chapter 25. So this is right here, chapter 25, programming project 1, right? The first one you have issue.
Yeah, it's the first
Okay.
one.
All right, so here's the one. And so this is the template you're using, right?
Yep.
Okay, good. All right, so here, so for a hint, so this is the hint right here. So this is the hint. Okay, so click on this, the hint.
Yeah, I went to that website.
Yeah, so you're gonna do the hint, and then you go down to this 25. All right, so this is programming project 1. So this is the check access tool. All right, did you use this one?
Yeah.
Okay. All right, so use this one. So if you use this one and so you enter your code, you put your code here, paste it right here. Okay, click on this automatic check. Okay. All right, did you see any difference between your code with the expected code, the output?
Um, the only difference that I saw was that all the inputs have to be on the same line,
Mm,
but that's why I'm
all
confused.
right. Oh, so that's the
Like,
all the input on the same line. Okay. Um, all right. Let me see here. This one here. Let me just get this. Go back here now. I'm gonna look at this now. This test code. All right. Would you mind to email me your code now?
um,
Yeah,
sure.
just email your code. I'm gonna see if I can.
Do you need it in like a PDF or just
No, just the source code. Yeah, just email me the source code. Yeah.
okay?
Yeah. All right. So here is the template. So let's see the template. All right. So this is the okay. I see what happens here. All right. Yeah. Email your code.
Okay. I just sent it.
Okay. All right. Oh no, just can you email me your entire code, everything?
Oh, yeah, sure.
Oh, I think what you have, you got it wrong. So when this node is null, you need to return -1. So that's the
Oh,
definition. Yeah. But anyway, email me the entire code. Yeah.
okay. All right. I just
All
sent
right.
it.
That's good. Just a second. So I'm going to show you the definition for the height in a binary search tree. Let's go to this chapter 25. So here's chapter 25, and let's look at the
Oh, it
so
works now. Like just resubmitted it with the -1 and it said it's fine.
yeah, just a second. I'm still need to do some checking. Okay, just a second. Hey, all right. Here, this is the so please pay attention to the definition. Oh, this is all right. So the definition for the height, and so right here, see, look, this is the definition for the height. The height of a tree that contains a single note is 0. Conventionally, the height of an empty tree is -1. All right. So
Okay.
this is when this root is null, you need to return -1. Okay. All right. So I still want to see your code here. And so this is the entire code you sent to me now.
Yep.
All right. I'm gonna see what happens now. To okay. All right, so I'm gonna paste your code right here. Okay, everything here, you pasted the code right here.
Yep.
And now do this automatic check. Okay. All right. So this is your output. All right, the height of an empty tree. So the height of
Oh.
tree. Let's see, maybe this is because my problem. I'm gonna to just make sure this is the error on my end. Okay, so the code. So this is the sample code. All right, so that's the my end. So I need to fix this. Yes, it is the an empty tree. So I missed that. Okay, so that's my issue. I need to get exactly the same to match the template. Okay. So that's the one here. Okay. All right, good. Well, thanks for bringing this to my attention. And any other questions?
Not at the moment.
Okay. So anybody else? Any questions?
No, I'm good.
Zach, I will look into your program and after this class and get back to you in the afternoon. Okay.
Okay, thank you.
Okay, good. All right. Anybody else? Any questions? If you see any problem, any inconsistency, just email me and I will check it and fix it. All right, just be reminded the assignment and for chapter 25 is due tonight. So let me just make sure to check it one more time. It is due tonight. So this is the chapter 25. And so here, I'm going to look at the due date is tonight. Okay. For 26 is due on October 20. And now we're going to move to introduce hashing in chapter 27. hashing is the technique for implementing the hash set and hash map. We know these two data structures are super efficient. You can perform search, insertion, and deletion all in order of one time. It's constant time. It doesn't matter how big your data set is. If you use these two data structures, and the time is super efficient. So how is this implemented? How do we get this super efficient data structure? This is what we're going to address in this chapter. We're going to introduce this technique, hashing. It has a lot of applications. So in data structures and in database systems, and you have huge amount of data, and how do you perform some operations super fast? So this is the it's used in database system for the physical database organization. It's using hashing. All right, so let's look at this next. Okay. It's actually really simple. It is using the array. So in the array, you can, if you look, you have index, right? And you can get the element in the index from this index in order one time. It doesn't matter how big your array is. So that's the way the physical and the computer and the memory and data organized in a way. It's this is the random access memory. So it's super fast for that. And also you want to put in an element at the specified index. If you want to just remove it and just wipe it out, so that's all the same time, all at one time. So what we're gonna have here is this array. It's actually it's the array. It's like array. It's essentially it's array, and you can have like a array list, and we call this is called a table. We can call this as a hash table, or we can call it associated array or a dictionary. So, and whatever the names, they're essentially the same. It's using hashing. So what we do is using this. We have a key. So if you have like a hash map, and so you have a key value. If you have just a hash set, you just have the key. So you use the key. You're going to map the key into an index in the hash table. So using a function called hashing. So this is hashing. Hashing is essentially a function that maps the key to an index in the hash table. So this is the diagram illustrate and the key idea in hashing. So you have this hash as a function using the key, and you get this index I. And now you can come here and to get this entry. So here is the value associated with the key. So this is the we call this as entry in a hash map. So this is entry here. All right. So your hash table is very large, larger than the amount of data you have, right? And the so you have space to put all the data in. And the another thing is about this the hash function. So if you can map the keys to different index, and that's going to be a perfect situation, and that's called a perfect hashing. So here's the perfect hashing is you have this function that maps the key to a different index. Perfect. That's a perfect. All right. perfect is not practical. So sometimes you have two different keys and they happen to map to the same index. So that case is called collision. And we're going to talk about how we're going to resolve the collision. So the hash function is also very important. So you can see that is you cannot get a perfect hashing. It's not possible for large amount of data. But you can try to minimize collisions. So you can have a hashing and that spread the data over the hash table. There are some collisions, but you're going to minimize the number of collisions. All right, so this is and here and the idea, and we're going to do for this hashing. All right, another thing we need to know that about this hashing is you need to look at these three key points for this hashing is in the Java API, we already have this method in the object class. In the Java object class, it's called the hash code. This is the method hash code, which returns an integer hash code, returns a hash code. And by default, the method returns the memory address for this object. There's an important contract for this hash code. It is, you should override hash code method, whichever the equals method is overridden to ensure two equals objects return the same hash code. So this is the first one is hash code and to be synchronized with the equals method. All right, during the execution of a program, invoke a hash code. This method multiple times return the same integer. It has to be consistent. All right, and the number 3 is two unequaled objects may have the same hash code, but you should implement the hash code to avoid too many such cases. So such cases, collision cases. All right, so please study this. Here is the hash code for primitive data types. They're implemented in Java API. So how, and we implement it so that we have minimal collisions. So for these primitive data types, for integer, you have byte, short, int, and for characters, and also for strings. So all this right here. So see how you do it. So now I'm going to bring your attention to this operators in Java and also in all the other languages. We have the bitwise operators. So these are the operators. We only use it mostly in the operating systems and also in the like when we get to the bit level manipulations. So the minimal unit, when we write a program, we deal with a byte. Byte is the minimal unit, but you can get into the bits. You can operate on the bits. So the bits here, this is the one here. It's the operators. We have the bitwise operators. So what is this one here? This symbol here. You have two, this like arrows, and they go into the right. So it's greater together. So this is the greater than together. This one here, this is the operator. It's called right shift. You're gonna shift this integer. Key is integer, and shift it 32 times position, 32 positions to the right. So that's the shift. And here, this symbol is exclusive OR. It's a bitwise exclusive OR symbol. So you can have this. Now, all of this is in Appendix G in the book. And so there's only one page. So this is the, please take your time and to look at this bitwise operations. And they are applicable to all the programming language, and they're almost the same. So this is the, in C, C++, in Python, they're all the same, bitwise operators. They're useful. So when we design our system software, and sometimes we get into the bit level and to improve efficiency. All right, so here's the, in this case here, we have this, this is a long, the key is a long value, long, this is the key is a long value. So, but this hash code has to be an int. So it's half size of the long value. So what we do is we're gonna do this shift this 32 bits. So that's the that's the size of int. You're gonna shift it, and you perform this exclusive OR with the key itself, and then cast it to int. So that is the last. So this is the 32 bits, the first half and second half, and performing the exclusive OR. So return an int value. Okay. So that's actually implemented, and in this in the Java API, and for this, the get the hash value for the long int. All right, so others you can look at this here is for the string. So what is the hash code for string implemented in Java API? So this is the one here. Okay. All right, now we need to do this is compressing the hash code. So look at the hash code is what you get from the hash code is an int. It's really large. It's int, but your table is small. You may have like maybe 100. The size of the table is 100. So the hash code has to be compressed into this hash table size. So what we do is use the remainder operator. So here, n is the table size, and this is your hash code. And so your index is going to be this hash code, remainder n. So that's called compressing hash code. So compressing your hash code. Now, it's a very interesting thing I want to alert you is this is if this n is an integer power of 2, okay? So like 4, 8, 16, 32. So this, if this n is this value, there's a very nice property is that you don't have to use remainder. You can just use this, the bitwise AND operator. So the bitwise AND operator to obtain the index. So hash code and n minus 1. So for example, you can look at this. If I have this n is 4, your hash code is 11. So look, 11 and 4 minus 1. So it is this is this 11. It's in the binary. It's 1011. And this 4 minus 1 is 3. It's 0011. If you have AND, so this is going to be bitwise. So the last bit, it's 11, so it's 1. And the second last bit, it's 1. And then all the remaining, because 0, so this is 00. So this is becoming, this is 3. So 11 remainder 4 is 3, and the same as 11 and bitwise AND operator, and with this n minus 1, it's also 3. So doing this is equivalent, but the reason we're going to choose this and over this remainder is that this is much faster. It takes less time, much less time than performing the remainder internally and by the CPU. The CPU time is saved. So please remember that when you design your this is software, it's Java API, and you're going to be used by all the applications. So you need to define things really, it's efficient. It's best efficient, and then it's going to make your overall the language fast. So this is something we're actually going to use it when we implement our own code. We're going to do this. All right. So there's another thing here. We're going to do a hashing. It's a supplemental hashing. Just to ensure hashing is evenly distributed, we're going to have a supplemental hashing function. So that's the one that's used in Java API. We're going to also use it when we implement it. You're going to see it's just spread it over and just to do kind of random, but it's a studied random. It's to be even. It's something like this. Okay. So this is, we don't have to just know it. This is the way it is done in the Java API, and exactly how, and this, why this is the and do a shift and the right shift. And so if you you're gonna see the difference here. You have 3 greater than sign. All right, this means you're gonna shift it, and with the sign, it's meant the retained. So please read the appendix, and you can see this, the difference. This is the appendix G, and see the operators. So what is this? This unsigned. So this means unsigned. Okay. All right. So now we're gonna see how we're gonna handle collisions. There are 2 approaches for handling collisions, and one is called open addressing, and the other one is a separate chaining. So open addressing is this: you find an open space. So here's the example. This is my hash table. We're gonna map the keys, this integers, and to the table. So we already have this. This is the size is 11, right? So you have the key 44 is there, and so 44 remainder 11 is 0. So it's 44 is here, right? So this number 4 is here. So 4 remainder 11 is 4, and 16 remainder 11 is 5, and 28 remainder 11 is 6. Okay, and 21 remainder 11 is 10. So they're all here in the right place. All right, so now we have a new element with key 26 to be inserted. So 26 remainder 11 is 4. It's right here. 26 remainder 11 is 4. So it's 22, and what is left is 4. So that's 4 right here. Okay, you're going to insert this 26 here, but it's already occupied. So that's a collision. So how do you resolve the collision? All right, so simple way we're going to do it, it's called a linear. The probing. It's called linear probing right here. So this technique is that we are going to find the next available location, empty location. So this is occupied, and go to next, it's occupied. All right, so now it is right here. 7 is good for this 26. So we're going to put 26 here. Okay, so now you're going to do a search for this 26. How do you do this? You come here again. So first it's 26. Remember 11 is 4. So there's no match, but you still need to look the next until it's a match or until this is empty. So it means there's nothing there possible. So this is linear probing. All right. We can look at the animation to see how this linear probing works is from here. If you put 26 here, and you're going to see this 26 is going to be inserted to right here. First, we're going to do a search. There's no 26. 26 is not there. Not in this hash set. It is not there, 26. All right, so now we're going to insert 26. 26 is going to be here. And now we do a search again. 26 is in the set. Is in. Okay, so that's okay. All right, so now, hey, I'm going to remove this 26. So let's remove it. So when you remove, be careful. It's, let's see, I'm going to remove 28. All right, so remove. So when you remove, the same thing here, you find 28, it's right here. It's index 6. All right, remove it, 28, remove. Okay, you need to put a special notation to mark that this one has been removed. It's available for insertion. But for search purpose, you have to go beyond this to continue to search because this is, it's the whole thing, it's a sequence. It has to be considered when you do a search. So I'm going to search for 26 again now. See, 26 is in. All right. So that is because the special mark, it's when you do a search and you have to go consider this one and then 26. Okay. So this is linear probing. Okay. All right. Now the linear probing has this obvious issue is this whole thing is a sequence. We also call it a cluster here. The cluster can be very large. So that you have everything together. The cluster, that's all very large here, cluster. All right, we want to spread it over. So try another way is this is alternative. It's called quadratic probing. Now, quadratic probing is this. It's linear probing is you're going to go next. Quadratic probing is you go quadratically. So this is right here is quadratic probing is you're going to go this index with this jump. So this is jump is quadratically j squared. So the location, you have this location is this, for this j is greater than or equal to 0. J is initially 0, then 1, then 2, 3, 4. So this is here is initially, so this is going to be the one, this one, k remainder n. So j is 0. And the next one, j is 1, is k plus 1. Okay, remainder n. And then and the k plus 4 and the k plus 9. So this is quadratically. So that's how you go quadratically. All right, so here's the example. So this is what we have already here. We have the key here. And now we have 26. So where 26 go? So here 26 right here. And then you jump the next one quadratically. So it's because j is 0. So this it's going to be this is the this one here. It's this quadratically. So the first is this, it's 0. So it's coming to this 4. And the next one is plus 1, it's 5. and then you get a plus 4. Is 4 plus 4 is 8. So it comes to this one right here. So this is quadratic proving. So now using this animation, so if you do a search for this 26, 26 is not in, okay? And do insert, and 26 is going to be put right here. It's here. All right, when you do a remove 26, okay, it's going to be like this. It's a marker there. So it's also, it physically doesn't look like they have a cluster, consecutive cluster, but internally it's just the same thing. You have a chain, it's a fixed pattern. So it doesn't really solve the problem. The real nice approach is this one, is the double hashing. So where you go, where you jump, it's going to be dependent on the key itself. So every key is different. So their pattern is going to be random. So that's here is coming to this double hashing. And double hashing is this, is we're going to hash one time. All right. So that's you get this initial map at the location. Then what you do, how you're going to jump is another hashing. It's a secondary hashing. So it's double hashing. So this is something like this. You're going to have this J. Okay, J is 0, 1, 2, 3. So here's J. And here is the hashing on the key again. So it's H prime. It's the second hashing. So H prime. So what you can see here in the example, we're going to have, this is H, the prime key. So this one is 7 minus key remainder 7. So this is the secondary hash function for H prime. It's secondary hash function. Okay, the key. So if you have this key is 12, it's going to be like this. 12 is going to be 2. Okay. All right. So this is for different key, you're going to get a different value. So that's really nice. Here's the example. This is 20. Okay, this is what we have already now. And so we're going to add something here. This one, we're going to have 12. The key is 12. So 12 is going to be here. 12 initially it's right here. And then 12 is going to be and here. So 12 is 2, right? The H prime 12 is 2. So that's what you're going to see. This is 12. Okay. And then you have this 2 times 2 here, 4. So this is the, but plus K is 1. So this is 5 right here. All right. So if you look this animation here and using this 12 and you do a search, 12 is not in the hash set. And now you're going to insert it. So 12 is going to be, remember 11, it's 1 here. So it's first right try here. And this, it's secondary prime. The jump is this this is the H prime 12 is 2. This is here. And then you're going to come to this location is 5. So it's inserted right here. Now you remove 12, it's like this. So this is double hashing. All right, so this is the handling collision using open addressing. And next time we're going to look at handling collision using a completely different approach. It's called using separate chaining. Okay. All right, so for this chapter, we're going to look at this hashing, the techniques, and then we're going to actually write our own implementation and to see, you're going to see how this is implemented and in Java API. So how hash set is implemented and hash map is implemented and why they are super efficient. All right, any questions?
Nope.
Okay, so if you have any questions on the programming projects, just email me, please. So I look at it and get back to you. Okay. Have a good day. Bye.
Bye.
Have a good one.
Yeah.